Yeah, so a very warm welcome once again to all the viewers of this channel. So today we are going to see some of the insights regarding the sliding window protocol, mainly essential protocols that we are going to discuss today. So, yeah, let me just share the screen so that it will be visible to all. Before we discuss regarding the elementary data link layer protocols, so we need to know regarding the basics of data link layer. So first thing is that data link layer is going to provide some of the services that are essential to the network layer. So here, what are the basic services that are provided by the data link layer is the framing concept, mainly regarding the framing aspects. And apart from this, it is going to provide error detection mechanisms, error correction mechanisms, and we can have some of the insights regarding the some of the protocols which are essential to that particular network layer is concerned. So we are going to transmit all the data in the form of frames. So frames may be a similar part that are available in the packets in the form of packets. We can have any number of bits in that particular frames. So in this we have some of the most important protocols that are the elementary data link layer protocols. In this, we have one of the most important protocols, that is the stop and wait protocol. So let us just imagine a small story before we discuss regarding this protocol. Let me just go ahead with the theoretical part first, and then we'll discuss the practical impartition as far as this protocol is concerned. So first thing is that we are going to send some of the frames to the network layer, to the other layer, from the sender to the receiver. So receiver should receive the frame. That is our ultimate goal. So here what happens is that we are going to transmit one frame. So frame, it may consist of any number of bits like zeros and ones combination along with the headers and footers added to it. So this is the frame that was transmitted from the sender to the receiver at one instance of time. So this is one of the most important aspects in the stop and wait protocol. So whenever the frame was sent from the sender to the receiver, whenever we get an acknowledgement from the receiver, then only we'll be able to send the next frame. So until and unless the sender gets an acknowledgement from the receiver, so sender was not enabled to send the frames once again. So this is the basic synergy of the stop and wait protocol. Let's just have a discussion regarding the analogy of this application, particular application is concerned. So now the basic problem that is revolving around the world is the water problem. So let us just imagine a village which consists of huge amount of villagers seeking for the water. And imagine there is only one well. All the villagers must come on this well to pick up the water and to go back. So this is the major synergy behind this stop and wait protocol. So how the frame is going to convert in this particular aspect. Let's just imagine there is a pot. Pot has some sort of production right, which has headers and footers together. So which is protected man. So with the help of the pot, villagers are going to carry out the water and they are going to dispatch to the receivers. So here the sender who is going to send the pot, he need to wait until the acknowledgement is received by the receiver. Suppose there are 3 people, they need to seek water from that particular village. So first person need to acknowledge that his work is completed, then only second person will be able to carry out the water. So this is the particular synergy as far as stop and wait protocol is concerned. So until and unless the receiver receives an acknowledgement from the sender, until the sender receives an acknowledgement from the receiver, so sender will not be in a position to deliver the packet once again, the frame once again. So this is the general synergy that happens in the stop and wait protocol. So once the acknowledgement is received, sender is going to send the next frame. So now here a case comes. If I am going to dig the water, put the water, and I am going to wait for huge amount of time. So there is some sort of time limit. There should be some sort of time limit for the sender so that sender can receive the packet, for the receiver to receive the packet. So there should be some sort of time frame. Then this wait can be overcome. So this is the major synergy. So if the wait time is long and the sender sending the packets frame is short, there will be some sort of issues that occur as far as the packet transmission is concerned. So these issues are to be addressed so that we can overcome the stop and wait problem. So let us just imagine this is the frame. So he is going to carry out the pot, which is unlike the frame, and digging the water. Water is put in this particular frame. So now he is going to send it to the receiver. Until the receiver receives an acknowledgement from the sender, receiver receives an acknowledgement to the sender, then sender will be able to send the next frames. Let us just imagine the same case with regard to the other protocols. We have two more important protocols, that is the sliding window protocol. In this, we have two aspects. One is go back and another one is select to repeat. So these two are the two important protocols in the sliding window protocol. Let us just imagine the sliding window protocol. So now in this sliding window protocol, we do not consider this pot. Let us just consider a tub. So there is one sender who is going to take the tub and picking up all the water in this particular tub, and he is going to distribute the water in the form of pots to each and every village. So now what this happens is that, so all the villagers need not come to the well to pick up the water. So this is the major synergy that happens in the sliding window protocol. So with the help of the tub, he is going to distribute all the water. So if the tub size consisting of 3 pots, so 3 pots will be a sliding window, a window size which is having 3. So we can have infinite amount of size, but it is not possible to access all the sizes in this particular window is concerned. So now sender is going to send the packets. So based on the frames. So based on the window size, we can distribute huge amount of packets. So now what happens when the distribution is going to done? So when there is any sort of issue in the third pot, so distribution should be done in 3 pots. So bucket was filled and this bucket should be distributed to 3 pots. So if the third pot got any sort of interruption, so what does this sender going to do? So sender going to send the pots once again, starting from the third pot. So suppose third pot got disrupted. So obviously fourth pot and fifth pot cannot have that particular water. So there will be some sort of issues in the distribution of the water. So if the third pot got some sort of disruptions. So if the third pot is disrupted, so sender should receive the data, should send the data from the third pot. The water should be distributed from the third pot, fourth pot, and fifth pot. So like this, the whole distribution should take place. Because the tub got trashed. So there is no water in the tub. And the third pot, in the third pot, while distributing the third pot, there is some sort of disruption. So the water cannot be distributed in the third pot. So there is some sort of interruptions that occurs in this particular third pot is concerned. So now what happens is that when there is the pot distribution in the tub, so third part got disrupted. So from the third part, the packets are going to send. So sender is going to send 3, 4, 5 and packets once again in the form of frames. So this happens in the sliding window protocol. Now let's just see the analogy of the go back N. So this is the aspect of go back N protocol. Now let's just see the select to repeat. So sender, while distributing, again the fourth pot got crashed. Now sender starts distribution only with the fourth. So the pot which is going crashed, only that pot will be acknowledged. So this is the select to repeat protocol as far as this analogy is concerned. Let us just see with another sort of analogy with the RRR analogy. So with the sliding window protocol, with the RRR analogy, let us just have a look regarding this particular analogy is concerned. So what is sliding window protocol? As I said, we are going to send huge amount of packets in the transmission based on the number of packets that we are transmitting in a window. In a window, we are going to send huge amount of frames. So if the frame size is, window size is 1, we need to send only 1 packet. If the window size is 2, we can send 2 packets. If the window size is 3, we can send 3 packets. 4, 4 packets. Likewise, we are going to sending up all the packets to the distribution. So based on the window size, we are going to distribute all the packets. So if the window size is 1, we'll be sending 1 packet. If the window size is 2, we'll be sending 2 packets. If the window size is 3, we'll be sending 3 packets. Accordingly, we are going to send all the packets to the particular destination point is concerned. So particular receiver is concerned. So now we are going to send multiple frames at once. Until and unless we receive an acknowledgement from the receiver, we'll be able to send the data once again in that particular window. So if there is any congestion that occurs in the window, all the packets will be disrupted, obviously. So this is the condition that occurs in the sliding window protocol. Now let us just imagine the sizes of the window. We have 3 sizes. So until there is some acknowledgement from the receiver, we need to send the packets once again based on the acknowledgements. So if we do not receive the acknowledgement, the packets should be retransmitted once again. So this is the general synergy in the sliding window protocol. So based on the window size, we'll be able to distribute any sort of packets. So sender is going to send the packets and receiver going to receive the packets. So if there is any packet loss or any timeout, we'll be able to resend the packets once again. So this is the synergy that occurs. So now coming to the stop and wait protocol, we'll be having the window size. So in the sliding window protocol, we'll be taking the window size as 1. And based on the acknowledgement that is received by the receiver, received from the receiver, sender will be able to send the data once again. So we'll be resend the lost packet onwards. From the lost packet, what we have lost, that can be retransmitted once again in the go back end. And specific lost packet will be transmitting as the select to repeat protocol. So this is the general synergy of the sliding window protocol. So let us just imagine the RRR analogy with this sliding window protocol. So let us just imagine the sender as RAM and receiver as beam, and the messages or the signals that are transmitted frames, which are nothing but the frames, are the arrows or the signals. So arrows are going to act as a signals or flag. Any sort of flag can be act as a signal. So let us just consider arrows as the frames. So RAM going to transmit some sort of frames, arrows to B. So why he need to transmit? That is the major question. Let us just imagine the storyline of RRR so that we can understand this particular aspect. So RAM going to send the packets to beam. So RAM is at one point and beam is at another point. So now RAM need to send the packets to the beam so that beam can avail the packets and overcome the war. So the major thing is the war field. Let us just imagine both are in the war field, and within the beam constraint, there are some soldiers, British soldiers available in this beam, available as the war field in the beam constraint, right? So now RAM going to send the frames to beam so that beam will crash all the soldiers and win the war. So this is the general storyline that happens in the sliding window protocol. So beam need to acknowledge RAM that some of the frames are being received. That means some of the arrows are being received. Let us just imagine there is some sort of water or the river in between RAM and beam, so that the communication will not get happened at once. So RAM need to cross the river and send the packets to the beam, so that beam will acknowledge with the help of some sort of signals or the whistles to RAM, so that RAM will be sending the frames once again. So based on the acknowledgement received from beam to RAM, the data can be processed once again. So beam should send, RAM should send some huge amount of packets to beam in the form of a window. So he cannot send 1 or 2 arrows at once because soldiers are many. So in order to conquer the war, he need to send huge amount of arrows, huge amount of frames. And beam need to acknowledge to RAM according to the constraints of the frames that are received by the beam. So this is the general synergy. So now this is the strategy. So RAM going to send 1, 2, 3, 4 packets to beam so that they are received. See, 1, 2, 3, 4 packets are being received by the receiver. So if any packet loss, the third packet got lost. So beam need to acknowledge RAM that I have lost third packet. Now RAM need to send 3, 4, 5, 6 packets starting from third packet to beam. So this results with go back and protocol. So if there is any loss in the fourth packet, so beam acknowledge RAM that fourth packet got lost. So now RAM need to send only the fourth packet. So this is the select to repeat protocol. So we have two synergies. One is go back and another one is select to repeat. So let us just see this analogy. The complete analogy was there in this particular synergy. So sender is RAM going to send huge amount of packets to arrows to beam. So beam catching all the arrows and acknowledging RAM that these arrows are being sent. So based on the window size has to be fixed and arrows are being transmitted in the form of flights. So acknowledge is in the form of gesture. As I said, we can have some sort of signals like whistles or some other communication with the help of words also. So that is also can be happened in the form of acknowledgement. So go back and as I said, when the third packet got lost from the third packet, beam is going to send the packets. So select to repeat, only the third specific packet is being sent, not all the packets from the third packet. What is the packet that is lost? That was sent to the RAM once again with the help of beam. So this is the major synergy that happens in the protocol as far as go back and select to repeat protocol is concerned. So if you watch the movie, you can have this particular scene aspect as beam RAM going to acknowledge beam that there are some disruptions that occur in this particular war field, that uh, there are some soldiers awaiting for you. They need to catch you and you need to be awakened so that you can protect from the soldiers. So this is the acknowledgement given by Ram. So Ram, he consisting of all the war fields, all the weapons. He is going to transmitting all the weapons to Beam. So now Beam got received those weapons. Now Beam will be able to see that he can win the war field, particular war. So this is the general synergy as far as go back and select to repeat protocols are concerned. So this is some of the sample example as far as go back and protocol is concerned. So this is the select to repeat. Only that particular as a constraint, we can see that there is one sort of acknowledgement that this is from the PC. So this is regarding the go back and select to repeat protocols. So are there any questions?